Let's take a look at how we can use quadratic functions to model a real-world application. So we're going to graph a function that matches a story, a word problem. We're going to look at an Olympic diver competing for a medal. Can you see it in your head? A diver standing on a diving board? Okay. His height in feet above the water can be modeled by the function f of x equals negative 3x squared plus 6x plus 24, where x is the time in seconds after he begins the dive. So we have to identify our variables. So we're going to let x equal the number of seconds after he begins the dive. Well, you know that your x-axis is the horizontal axis. So let's go ahead and label our axis down here. X is the number of seconds, so I'm going to write that. Number of seconds after he leaves the diving board, after he begins his dive. And then our y is the height of the diver. So it's height, so I'm going to write the word height, and then remember we put our measurement inside the parentheses. Okay, so we're measuring our height in feet. Now, where do we go from there? Okay, I have a note here. There's no y in our function. This is written in what we call function notation, where it says f of x. Some x goes in, some y will come out. So whatever x value we would put in, sometimes it's written in here. F of x just means y equals. So let's rewrite that and show that. Y equals negative 3x squared plus 6x plus 24. They're the same function, just using slightly different notation. We're going to take our a, b, and our c. Our a is our negative 3. So what does that tell us? There's something important. That means that this is going to open downward because our a is negative. Our b is 6, and our c is 24. Remember, that's key in standard form. Let's calculate our axis of symmetry. The formula, x equals the opposite of b divided by 2 times a. So I'm going to replace my variables with the parentheses, and I'm going to fill in my values. A is a negative 3, and whoops, that's supposed to be the b. So I need to change that value to be 6 because that's my b value, and the b goes in the numerator. A is negative 3, that belongs in the denominator. So I have as a result negative 6 divided by negative 6, which simplifies to 1. So the equation for the axis of symmetry is x equals 1. To find my vertex, I take my function and I write y equals negative 3 times my x squared plus 6 times my x plus 24. Replace the x value with the x we just calculated. Follow order of operations. That means do your exponents first. 1 squared is 1. And then our next step, we will do our multiplication, and then we'll do our addition and subtraction. So 3 times 1 would be 3. Negative 3 times 1 is negative 3. Positive times positive is plus. 6 times 1 is 6. 24. Simplifying further, I get y equals 27. So now I have to name a point. Vertex is a point. Don't forget this. We need the whole thing. X is 1, y is 27. Label the x and y axes. We did that already. We're going to graph the axis of symmetry as a dotted line. So where x is 1, I'm going to start at the bottom so I can find the right spot. I'm going to put a dashed line just so I can use that as a guide. Next, I'm going to plot my vertex. So 127 will be a point right here. I'm going to graph and reflect the y-intercept. The y-intercept is my c. So at 24, I put a point. It's 2 spaces to my axis of symmetry, 2 spaces on the other side. And now I just need to find one more point. So I'm going to go ahead and do that. I'm going to pick the number 2 because it's a number that I haven't used yet. Oh, no, I did. I used 2. So let me go to 3. So let's say when x equals 3, And then I take my function rule and I replace the variable x with the number I chose for x so I can find my y. And when I'm done, I'll have an ordered pair where the x is the number I chose, the y is what I get as a result. Continuing the calculations, following order of operations, it gives me negative 3 times 9 plus 6 times 3 plus 24. Multiplying out, I get y equals negative 27 plus 18 plus 24. Continuing to simplify, y equals negative 9 plus 24. Y equals 15. So that's my point, 3 comma 15. I plot that, 3 and 15. Okay. Now normally I would reflect this, but you notice if I reflect it, it goes off the coordinate plane. That's because anything before the time of 0 is a solution, but it's what we call extraneous because it doesn't work in this word problem. So I do not have to reflect that. So now I'm just going to, as quickly and as smoothly as I can, connect those points, continuing the pattern down, okay, into the end. So I have, oops, I'm sorry, I fell out my parabola. I have now shown from everything we practiced before, just from the function, what the graph would look like. Okay, so now we have to look at what the vertex means, because that's our goal for today. The vertex in this story is the highest point that the diver will reach. The diver will reach a height of 27 feet after 1 second. And then we write that. The diver reaches you can say his maximum height, or you can just say 27 feet after 1 second. And that describes your vertex. Done.